Hello and welcome back to Global Works TV. Wood has always been at the heart of American life, building our homes, our barns, and our towns. From the towering pines of Mississippi to the precision mills of Washington, we're about to witness industrial power that'll make you remember why American craftsmanship built this great nation. Here's something fascinating that'll give you goosebumps. The southern pine forests surrounding this mill have been producing timber for over 200 years, yet they're more productive today than ever before. That's because modern forestry practices, including selective breeding and genetic improvement programs, have created pine trees that grow 40% faster than their wild ancestors. These super pines can reach harvestable size in just 25 to 30 years, compared to the 50 to 60 years it took in the old days. The science behind this is remarkable. Foresters have identified specific genetic markers that control growth rate, wood density, and disease resistance, essentially creating the Formula One race cars of the forest world. NTHE twin band head rig we mentioned earlier represents over 150 years of sawmill evolution. The very first band saws were invented in 1808 by William Newberry in London, but they were considered too dangerous and unreliable for commercial use. It wasn't until the 1870s that French immigrant Jacob Hoffman perfected the design in Fort Wayne, Indiana, creating the first successful commercial band mill. What made his design revolutionary was the combination of thin, flexible steel and precise tensioning systems. Today's Weyerhaeuser head rig uses Swedish steel that's been through a proprietary heat treatment process, creating blades that maintain their edge through thousands of cuts while running at speeds that would have been unimaginable to those early pioneers. NBUT. Here's a nugget of history that connects us to America's past. Mississippi's timber industry played a crucial role in rebuilding the nation after the Civil War. The yellow pine forest provided the lumber that built entire cities from Chicago to San Francisco. In fact, the Great Chicago Fire of 1871 created such demand for southern pine that entire railroad lines were built just to transport Mississippi lumber north. The economic impact was so significant that by 1900, Mississippi was producing more lumber than any other state in the Union, over 2 billion board feet annually. Today's Magnolia Mill, while processing far less volume than those boom-era operations, produces lumber of quality and consistency that those old-time lumbermen could never have imagined. Now, if you've been around long enough to remember when lumber mills were smaller, family-run operations with just a few saws and a lot of elbow grease, you're going to be amazed at what we're about to show you. This isn't your grandfather's sawmill, though the spirit of American craftsmanship runs just as deep. Weyerhaeuser, founded back in 1900 by Frederick Weyerhaeuser, a German immigrant who understood the value of America's vast forests, has been a cornerstone of our nation's lumber industry for over 120 years. The Magnolia facility represents the pinnacle of modern timber processing, where southern pine logs are transformed into the lumber that builds homes, offices, and dreams across America. Picture this. Every single day, this mill processes enough timber to frame about 40 average-sized homes. That's roughly 200,000 board feet of lumber rolling off the production line daily. But here's what makes it truly remarkable. They achieve this with a precision and efficiency that would make those old-time mill workers shake their heads in wonder. NTHE journey begins at the log yard, where massive southern pine logs arrive by truck and rail. These aren't just any logs, they're carefully selected specimens, some measuring up to 40 feet in length and 24 inches in diameter. The yard itself spans nearly 50 acres, with logs sorted by species and size, using GPS-guided equipment. It's like a choreographed dance of massive timber, where every log knows its place. NTHE real magic starts when these logs meet the mill's primary breakdown system. At the heart of this operation sits a marvel of engineering, a twin-band head rig that can slice through a 24-inch log like a hot knife through butter. This isn't just one saw, mind you, but a sophisticated system with two parallel band saws, each blade measuring nearly 12 feet in length and running at speeds that would terrify most folks. What makes this system special is its scanning technology. Before each log even touches the blade, laser scanners map every inch of its surface, detecting knots, grain patterns, and defects faster than the human eye can blink. The computer brain behind this operation then calculates the optimal cutting pattern in milliseconds, maximizing the yield from every single log. It's like having a master craftsman with 100 years of experience making decisions in the time it takes to snap your fingers. The cant, that's what we call the squared timber that comes off the head rig, then moves to the gangsaw. Now this is where things get really interesting. The gangsaw isn't just one blade, but a series of circular saws arranged in a frame, working together like a well-oiled orchestra. In one pass, they can transform a cant into multiple boards of predetermined thickness. The precision here is remarkable. We're talking tolerances measured in thousandths of an inch. NBUT. wait, there's more to this story. Each board that comes off the gangsaw isn't finished yet. Far from it. They travel on a series of conveyors to the edger, a machine that would make any woodworker green with envy. The edger uses multiple circular saws to trim the rough edges and create perfectly straight, parallel sides. The speed is breathtaking, boards flying through at 1,000 feet per minute while maintaining tolerances that would impress a Swiss watchmaker. Temperature and moisture control play crucial roles throughout this process. Southern pine, like all wood, is a living material that responds to its environment. The mill maintains precise humidity levels and temperatures to prevent warping and ensure consistent quality. The lumber travels through climate-controlled sections where it's gradually conditioned, much like aging fine wine. One of the most fascinating aspects of Weyerhaeuser's operation is their grading system. Every single board is individually scanned and graded by sophisticated optical scanning equipment. These machines can detect grain patterns, knots, and structural characteristics that determine each board's final use. Some pieces will become structural lumber for home framing, others might end up as appearance-grade boards for furniture making. NTHE Mill's efficiency extends beyond just processing speed. Their computerized optimization system tracks every log from entry to final product, ensuring minimal waste. Wood chips from the edging and trimming operations don't get discarded. They're collected and sold to paper mills. Even the sawdust has value, used for everything from landscaping to biomass fuel. It's a beautiful example of the old American principle of waste not, want not. NTHE sorting and packaging systems are equally impressive. Automated stackers arrange lumber by grade and dimension, while strapping machines secure each bundle with military precision. The lumber then moves to covered storage areas, where it awaits shipment to lumber yards and construction sites across the Southeast. What truly sets the Magnolia Mill apart isn't just its technology, it's the skilled workforce that operates these magnificent machines. Many of these operators are second and third generation mill workers, carrying forward traditions while embracing innovation. They understand that behind all this impressive machinery lies the same fundamental mission that drove their grandfathers, turning nature's gifts into the materials that build America's future. And as we watch these massive logs transformed into perfectly dimensioned lumber, we're witnessing more than just manufacturing. We're seeing the continuation of an American tradition that stretches back to our nation's earliest days, when lumber camps and sawmills were the beating heart of frontier communities. Let's journey north to the beautiful Pacific Northwest, where the timber industry has deep roots, stretching back to the days when loggers floated massive Douglas fir logs down rushing rivers. Here in Kettle Falls, Washington, Boise Cascade operates a facility that represents the evolution of American wood processing, a state-of-the-art engineered lumber production plant that would amaze those pioneering lumberjacks. Here's a piece of engineering history that'll blow your mind. The I-joist technology we're seeing today actually began during World War II, when aircraft manufacturers needed lightweight, yet incredibly strong structural components. The laminated wood techniques developed for aircraft wings and fuselages eventually found their way into construction, but it wasn't until the 1960s that someone had the brilliant idea to apply these principles to floor joists. The first engineered I-joists were actually produced by Truss Joist Corporation in 1969, using a process that combined the strength advantages of steel I-beams with the workability and cost-effectiveness of wood. What's remarkable is that these early I-joists were 50% stronger than solid lumber of the same depth, while using 50% less wood. A classic example of American ingenuity making more from less. NTHE radio frequency bonding process is particularly ingenious and borrows technology from an unlikely source, the food industry. The same electromagnetic principles used to heat your microwave dinner are employed here to cure adhesives instantly throughout the thickness of the wood composite. This technology was first developed by Cryogeny Corporation in the 1950s for drying foods. But clever engineers realized it could revolutionize wood bonding by heating materials from the inside out, rather than relying on slow heat penetration from surfaces. And Boise Cascade has been an American success story since 1957, but their roots in forest products go back even further. What makes their Kettle Falls operation special isn't just the scale, though processing millions of square feet of engineered lumber annually is certainly impressive. It's how they've married traditional woodworking principles with space-age technology. This facility specializes in producing engineered I-joists, those remarkably strong structural beams that look like steel I-beams but are made entirely from wood. If you've built or renovated a home in the last 20 years, chances are good that Boise Cascade I-joists are holding up your floors right now. NTHE process begins with carefully selected lumber strands, primarily Douglas fir and southern yellow pine. These aren't random wood pieces. Each strand is precisely cut to specific dimensions and dried to exact moisture content levels. The lumber moves through massive kilns where temperature and humidity are controlled to the degree, ensuring each piece reaches the optimal 8 to 12% moisture content. Here's where the magic happens. The strands are fed into a sophisticated-oriented strand board manufacturing line. Picture a machine the size of a small factory building, where thousands of wood strands are arranged in specific patterns and bonded with specially formulated adhesives. The precision is astounding. Each strand is oriented to maximize strength properties, creating a web that's stronger than solid lumber of equivalent size. NTHE web material then moves to the assembly line, where it meets the lumber flanges, the top and bottom portions of the I-joist. These flanges are made from laminated veneer lumber, created by bonding multiple thin layers of wood veneer with waterproof adhesive. The bonding process uses radio frequency heating, where electromagnetic waves cure the adhesive from the inside out in just minutes. NTHE continuous pressing operation is truly something to behold. The assembled I-joists travel through a press that's nearly 400 feet long, where precise pressure and heat create bonds stronger than the wood itself. The press applies thousands of pounds of pressure while maintaining exact temperatures, creating joints that will outlast the building they support. Quality control at every step ensures these engineered beams meet or exceed the strength of traditional solid lumber while using 50% less wood. Each I-joist is tested for strength, stiffness, and dimensional accuracy. The final products are so consistent that architects and builders can specify exact load capacities with complete confidence. What's remarkable is how this represents the American spirit of innovation, taking abundant renewable resources and engineering them into products that are stronger, more consistent, and more environmentally responsible than what nature provides on its own. These I-joists will span longer distances, carry heavier loads, and last longer than the solid timber beams our ancestors used. Now let's travel across the Atlantic to explore how German engineering precision has revolutionized wood processing worldwide. Moeringer Anlagenbau represents the pinnacle of timber processing technology, designing and building automated production lines that operate with clockwork precision in mills from Canada to New Zealand. Here's a story that perfectly illustrates German attention to detail. The laser scanning technology used in modern Moeringer systems can detect internal defects in logs that are invisible to the human eye, using the same principle that medical CT scanners use to see inside the human body. This technology traces its roots back to the 1960s, when German physicist Dr. Heinrich Rohrer was experimenting with electron beam scanning at IBM's Zurich laboratory. His work eventually led to scanning tunneling microscopy, which won him the Nobel Prize in Physics in 1986. The same principles of wave reflection and analysis that reveal atomic structures now help sawmill operators see inside logs, detecting everything from insect damage to moisture variations to stress fractures caused by wind loading in the forest. NTHE precision of German sawmill equipment is legendary, and there's a fascinating reason why. After World War II, Germany's manufacturing industry had to rebuild from scratch, and they made a conscious decision to compete on quality rather than quantity. The concept of Deutsche Qualität, German quality, became a national obsession. In the 1950s and 60s, German machine tool manufacturers began applying aerospace-level precision to industrial equipment. The bearing systems in a modern Moringer band mill, for example, maintain tolerances measured in thousandths of an inch over millions of operating cycles. These bearings use ceramic balls that are perfectly spherical to within 0.000025 inches. That's smoother than a mirror and rounder than the Earth relative to their size. What's truly remarkable about modern German sawmill technology is how it incorporates lessons learned from completely different industries. The hydraulic positioning systems, for instance, use technology originally developed for submarine periscopes and tank gun turrets, where precision movement under extreme conditions was literally a matter of life and death. The software algorithms that optimize cutting patterns borrow heavily from the airline industry's route optimization programs and the automotive industry's just-in-time manufacturing principles. It's a perfect example of how German engineers never reinvent the wheel. They take proven concepts from other fields and refine them to perfection for their specific application. Founded in the heart of Germany's Black Forest region, how fitting for a company that would become synonymous with wood processing excellence. Moringer has spent over 4 decades perfecting the art and science of automated lumber production. Their systems represent what happens when meticulous German engineering meets the demands of modern timber processing. What sets Moringer apart isn't just their engineering prowess. It's their understanding that every log is unique, and their systems must adapt accordingly. Their fully automated production lines begin with 3D laser scanning technology that would make NASA engineers proud. As logs enter the system, multiple laser scanners create detailed 3-dimensional maps, identifying knots, grain patterns, defects, and optimal cutting solutions in real time. NTHE log positioning system is a marvel of mechanical precision. Hydraulic arms with the strength of giants, yet the delicacy of a surgeon's hands rotate and position each log for optimal yield. The positioning accuracy is measured in millimeters, ensuring every cut maximizes the valuable lumber that can be extracted from each log. NTHE primary breakdown equipment represents the cutting edge of sawmill technology. Moringer's band mills operate with blade speeds and feed rates that push the boundaries of physics. The blades themselves are marvels of metallurgy, Swedish steel sharpened to tolerances measured in microns, running on wheels engineered to maintain perfect tension through millions of cutting cycles. NBUT. Here's where German engineering truly shines: the optimization software. Every decision, from initial log scanning to final board grading, is made by artificial intelligence systems that learn and improve with every log processed. The computer systems analyze thousands of variables simultaneously, making cutting decisions that maximize value while minimizing waste. NTHE Cant processing systems showcase automation at its finest. After primary breakdown, cants move through a series of operations that would have required dozens of skilled operators in traditional mills. Automatic turning stations, precise thickness optimization, and defect detection happen seamlessly, with each machine communicating with the next to ensure perfect coordination. The board edging systems exemplify Moringer's attention to detail. Multiple circular saws work in perfect harmony, trimming edges with precision that creates perfectly parallel sides and square ends. The speed is remarkable, boards moving at nearly 20 meters per minute while maintaining tolerances that rival precision machining operations. Advanced grading technology represents perhaps the most sophisticated aspect of these systems. Optical scanners using multiple light spectrums analyze grain patterns, moisture content, density variations, and structural characteristics. The grading happens at production speed, with each board automatically sorted into appropriate grade categories. NTHE material handling systems tie everything together with Germanic efficiency. Automated conveyor systems move lumber through the mill without human intervention, while sophisticated tracking systems monitor every board from log to final product. Nothing is lost. Nothing is forgotten. The system knows the location and status of every piece of lumber at all times. Quality control systems built into every stage of production ensure consistent output that meets the most demanding specifications. Thickness variation, moisture content, and dimensional accuracy are continuously monitored and automatically adjusted. The result is lumber quality that was impossible to achieve with traditional methods. These systems represent more than just technological advancement. They embody the marriage of old-world craftsmanship with new-world innovation. The precision and attention to detail that characterized master craftsmen of centuries past is now built into machines that never tire, never lose focus, and continuously improve their performance. What makes Moehringer systems truly remarkable is their adaptability. Whether processing massive Douglas fir logs from the Pacific Northwest, tropical hardwoods from South America, or fast-growing pine from Scandinavian forests, these systems adapt their processing parameters to optimize yield and quality for each species. NTHE environmental consciousness built into these systems reflects modern values while honoring ancient respect for the forest. Waste minimization isn't just good business, it's good stewardship. Every chip, every sliver, every piece of sawdust has a purpose and destination in the circular economy of modern wood processing. From the forests where it all begins, to the sophisticated mills where logs become lumber, we're seeing the best of both tradition and innovation working hand in hand to build tomorrow's America.